In this video, I'll be explaining exactly what I do to collect Watch for Rolling Rocks in 0.5 A-presses. But first, we need to clear something up, because every time I post a half A-press video, I get the same comments over and over asking what it means, even though I always have a whole paragraph in the description explaining it, which even starts with, if you're wondering what a half A-press is, read this before commenting to ask. But maybe what you get isn't a paragraph. Maybe you guys need an example. So, consider Wing Mario Over the Rainbow. Not even the whole song. Just consider getting to that cannon platform, which is a necessary part of getting started. So, how many A-presses does it take to get there? Well, if you say 0, that's wrong, because then Mario can't go far enough. If you say 1, well, it's true that Mario can get there with 1, but we can do a little better. We can do it in half an A-press. To do that, we start the level already holding A, and then we use that A-press to reach the platform. Now, hold on. I know what you're thinking. An A-press is an A-press. You can't say it's only a half. Well, TJ, Henry, Yoshi, hear me out. An A-press actually has 3 parts to it. When A is pressed, when A is held, and when A is released. And together, this forms one complete A-press. Now, usually, it's the pressing that's useful, because that's the only part that makes Mario jump. However, sometimes it's sufficient to just use the holding part, which allows Mario to do little kicks, to swim in water, to fall slowly while twirling, and to fall slowly with the wing cap. And as for the release, well, there's currently no cases where that's useful or important. So, now, if we map out the required A-presses for Wing
Mario is not the word, so why is he here?
Press A to launch from the
Oh shit, Mario, is he real?
Press A again to launch from the second cannon. So, how many A-presses is that total? Well, it appears to be 3. And if we were doing this star in isolation, then yeah, it would be 3. But in a full game A-button challenge run, there are other A-presses that occur earlier in the run, such as this A-press needed to get into the course. So, if we take that A-press into consideration as well, then how many A-presses would it take? The naive answer would be 4, 1 to enter the course, and the 3 within the course that we established earlier. However, we can do better. We can actually do it in 3 by simply holding out the first A-press to be used for the half A-press, because the half A-press only required A to be held, not actually pressed. So in this fashion, Wing Mario Over the Rainbow only adds on an additional 2 A-presses to the run, since the first A-press just leeches off of a previous A-press. So to capture this phenomenon, we call it 2.5 A-presses. On a single star basis, you'd round that up to 3, but in a full game run, you'd round it down to 2. So, in conclusion, since that first A-press counts in some contexts, but adds no additional A-presses in other contexts, we refer to it as a half A-press. So, going back to the video, you can see that I start the level with the A button already held, as indicated in the bottom left corner. And so in the full game run, this A-press will just leech off of a previous one, and so it won't incur an additional A-press. Okay, glad that's explained. Now, what am I doing in the video? Here, I'm using a trick called Scuttlebug Transportation. You see, like most enemies, Scuttlebugs have a home, which is just a point in 3D space, and they'll patrol a certain radius around that point. So, if Mario enters that radius, they'll lunge at him to attack. But, unlike most other enemies, a Scuttlebug's home can change positions, because if a Scuttlebug bumps into Mario, the Scuttlebug's home will update to where the Scuttlebug was when the collision occurred. So, by strategically luring the Scuttlebug to the edge of its radius and bumping into it, we can effectively transport the Scuttlebug and its home. So, that's what I'm doing here. Note that we can't actually transport a Scuttlebug outside of its new lagoon. They actually get stuck at the door. So, if your dream was to bring all the Scuttlebugs together to one big jamboree, I'm sorry, but it's not going to happen. Also worth noting is that Scuttlebugs will actually disappear if they walk into a wall while too far below their current home. So I do have to be careful to avoid that. It's pretty weird if you've never seen it before, but I'm pretty sure they did it so that if a Scuttlebug jumps into a hole, it wouldn't just walk around down there. Anyway, I'm transporting the Scuttlebug to the corner right below the Watch for Rolling Rocks star, because next I do a trick called Scuttlebug raising, and here's how it works. when Mario's in the room, or standing in a small region right outside the door, indicated here in yellow. So, if Mario isn't in the Rolling Rocks room or in the yellow region, then the room will be completely black, and everything in the room will be invisible and won't move. Conveniently, this allows us to raise the Scuttlebug by performing the following steps. First, Mario enters the Scuttlebug's radius. Although the Scuttlebug is invisible and can't move around, it can still turn towards Mario and activate a lunge. Then, Mario leaves the radius and the Scuttlebug returns to facing its home. Next, Mario enters the yellow region to activate the Scuttlebug. The Scuttlebug will perform the lunge that it started, but cleverly, we have Mario exit the yellow region right when the Scuttlebug is at the peak of its trajectory, thereby deactivating it so it won't fall down. And finally, since the Scuttlebug moves past its home, it turns around to face its home once more. Now, we've gotten all the height we could out of the Scuttlebug's current lunge, but that's no problem, because we can just activate another lunge by repeating this procedure. Activate a lunge while the Scuttlebug is deactivated, reactivate the Scuttlebug just for the upwards portion of its trajectory, and then repeat. As simple as that. So that's what I do here, and I have a second screen to show it from the Scuttlebug's perspective. Fortunately, the Scuttlebug's radius isn't a sphere, but a cylinder that extends up and down infinitely. So really, no matter how high the Scuttlebug gets, we can continue to enter its area to activate its lunges and move it upwards. There's no limit to how high we can raise it. Now, it's worth noting that I only while I'm not inside its radius, so the Scuttlebug will always lunge towards its home and not towards Mario. This causes the Scuttlebug to effectively travel straight up above its home. But alternatively, I could have activated the Scuttlebug while inside of its radius, and in that case, the Scuttlebug would always lunge towards Mario instead of towards its home, so it would actually make its way towards the door and then travel straight up from there. That method's actually a little faster because we wouldn't have to wait for the Scuttlebug to turn back towards its home before each activation. However, it wouldn't work for what we're doing because we need the Scuttlebug to be right next to that corner. In fact, the top of that corner has a special property which we call a misalignment. Basically, in the game's code, there's a discrepancy between the way the game handles collision checking with floors versus walls. This results in a 1x1 minute area where Mario could get onto the floor without being pushed away by the walls. And if Mario's less than 79 units under a floor, he'll snap right up onto it. So that'll be important later for getting up there. Anyway, now it's time to build up some speed. And I mean a lot of speed. So to get that speed, we're going to use a trick called hyperspeed walking. And here's how it works. You probably already know that there are some slopes in the game that are too steep to stand on. Mario just slides off of them. But did you know that you actually can stand on these slopes if they're submerged in shallow water? In fact, the underwater portion of these slopes has a special property. If you try running uphill on them, you'll end up running backwards at increasing speed with no upper bound. But in most circumstances, this would cause us to end up in the water before building up any real speed. We can get a little more speed by running nearly parallel to the slope, but ever so slightly uphill. But eventually the slope runs out, or we move too fast to round a corner. But there are some ways to have Mario walk while staying in place. For example, if there's a wall perpendicular to the slope, then we can use that. That allows Mario to build up quite a bit of speed before he breaks through. However, if the wall isn't perpendicular to the slope, then we end up sliding down into the water. That's because walls are really just rectangles that push Mario out perpendicularly. So, if Mario moves into a wall at an angle, the game will calculate his intended next position, then the wall will push that position out, and then Mario ends up having a net movement along the wall. So ultimately, he'll end up moving into the water. So, is all hope lost? Well, no. Because Tyler Caney figured out that we could actually make use of the gate. You see, the bottom of the gate is a ceiling, and the game doesn't like putting Mario too close to the area right under a ceiling, because it doesn't think he fits. So, if we have Mario move backwards into the ceiling, the game will choose not to move him. So we're free to build up speed in place, but not infinite speed, because we'd end up breaking free if our speed moved past the gate. So what do? We turn to redirect our speed out of bounds. Notice that we now have enough speed so that our intended next position is past the wall and out of bounds. bounds. And since the game doesn't like placing Mario out of bounds, it doesn't move him, and instead just lets him stay in place, just like the ceiling. But unlike the ceiling, out of bounds goes on forever, so we can essentially build up as much speed as we want without having to worry about breaking free. So now I do just that. Open the gate, use the ceiling of the gate to build up some speed, and then redirect my angle out of bounds to build up the rest. Now, you're probably wondering what I'm going to need all this speed for. After all, I do build up speed for 12 hours. But to answer that, we need to talk about parallel universes. And if you thought my other tangents were complicated, just you wait. Okay, so Mario's position is a floating point number, but it's converted to a short when the game uses it to test for collision with floor triangles. In other words, Mario's position can basically be any decimal number, but it's converted to an integer between negative 32,768 and positive 32,767 inclusive. So, any fractional portion is truncated, and numbers too big or too small are moved into this range using the modulo operator. Graphically, that means that the position used for floor detection is always inside of this box. So if Mario's in that box, then his actual position and the position used for floor detection are the same, albeit maybe off by a single fraction due to the truncation. But if Mario leaves that box, then his actual position and the position used for floor detection will separate, since the position used for floor detection will just loop back around to remain in the original box. So now I ask you this. Here's the course. So if Mario is standing way over here where there's no land, but the position used for floor detection is on land, can he stand over here? The answer is yes. As far as the game sees it, Mario is in fact above land over here because the game actually checks for land over here. So, for all intents and purposes, there is essentially land over here, a copy of the original map. And this is what we call a parallel universe, or a PU. And this applies to every one of these boxes, so there's actually a grid of nearly infinite PUs. Here is a to-scale diagram of the PU grid. As you can see, the PUs are actually pretty far apart, but I'll be taking some creative liberties and drawing them closer together for the sake of clearer visuals. Now, PUs aren't as glamorous as you might think. The graphics are only found on the original map, so the PUs are completely invisible. Furthermore, PUs have no objects, like elevators or item blocks, no enemies, no items, like coins or stars, and not even any walls, so really, it's pretty barren. Furthermore, the N64 console will actually crash if you go to a PU and let the camera follow you, but luckily, we can avoid that crash by fixing the camera in place on the original map before leaving it, though that does make it even harder to tell what's going on in the PUs. So, as you just saw, you can travel to a PU if you have enough speed, but it's not as simple as you might think. If you have just enough speed to reach the PU one over, it won't actually work. That's because the game actually checks if Mario is above land at each quarter step of his movement. That means the simplest PU movement is moving over 4 PUs at once. That way, each quarter step is above land and therefore valid. For simplicity, we call this quadruple PU distance 1 QPU. Now, up until this point, I've been glossing over a very important detail, which I now need to clear up. What if I told you the distance Mario moves isn't necessarily equal to his speed? For example, look how fast Mario moves at 31 speed on this flat slope, and now compare it to how fast he moves at the same speed on this steeper slope. In both cases, he has about the same speed, but clearly he's moving at different rates. That's because the distance Mario moves is only a portion of his actual speed, and this portion depends on the slope of the ground. The steeper the slope,